Hey, welcome back to my channel. This is Moses. We are in this engineering mechanics series, and today's lesson is about collinearity, coplanarity, and concurrence of forces. Collinear forces, coplanar forces, and concurrent forces. What are these? So let's take this line. It could be at any angle. Let's take a straight line, okay? And let's consider these three different points that you see here on the screen. Now let's say this force B is applied on the point, trying to push the point, of course, towards the line above, towards the right. And this force R is applied on the point, pulling the point rather than pushing the point. And let's say this force G is actually in the opposite direction compared to the other two, and it is pulling the point as does the force R. Now these three forces are said to be collinear because they are on the same line. Collinear means collinear. So they share the same line. They are on the same line. They must act on the same line. It doesn't matter where they act, on which point they act, whether they push the point or pull the point, or you could move the point around, doesn't matter, as long as they are all on the same line. Okay, now let's say if this force B moves to another line parallel to this original line, and we call it B dash, then this B prime or B dash is parallel to the other two forces R and G, but it is not collinear. So you get the point. Right, so I want to mention the principle of transmissibility in connection with the collinear forces. Let's say now this is the line on which the forces are applied. Let's say we apply a force of 20 newtons on the left hand side of this box. It is the same as applying the force in the center. And it is also the same as applying the force on the other side, on the right hand side. So whether it is on the left or is it in the center or on the right, it doesn't make a difference. The whole result will be the same. That's the principle of transmissibility. Now using the principle of transmissibility, we can derive another principle. We call it as a principle of superposition. Superposition. Let's take this box again, and let's say we are applying a force of 50 newtons on the left side, and then we apply another force of 20 newtons on the right side. Now going by the principle of transmissibility that we looked at in the previous slide, if I move this force back to the other side, it shouldn't make any difference. Now that we have moved this red force onto the side, you can see clearly the 50 newtons and the 20 newtons, they're overlapped with each other. It is pretty straightforward. You can apply this and put a 30 newtons instead, and it will not make any difference. They are all one and the same. The point is, if you simplify the forces and put an equivalent force on the same line of action, of course, then there is no problem, and that is the principle of superposition. Both are related, as you can see. So we have covered now this collinear forces or collinearity. All right, coplanar forces. What are coplanar forces? As the name suggests, they all share the same plane. When you say the same plane, what plane are we talking about? The XYZ planes, they're not XYZ axis there actually. The planes are XY plane and YZ plane and ZX plane that we could think of in a three-dimensional setup. And so obviously those three could be planes. And if the forces are lying on those planes or any other plane that is parallel to XY or parallel to YZ or parallel to ZX, or in fact in any other direction, they are said to be coplanar. Now the planes could be at any angle, as I have suggested a bit earlier. Now let's take this dodecahedron, which has 12 faces, and each face, as shown in different color in this picture, is a plane. And in fact, if you extend that face to an infinite level, it's still the same plane. So if the forces are lying on that plane, then they are coplanar. That's the point I'm trying to make. Okay, it doesn't matter which plane is it, in which direction is it oriented, as long as the forces are on that plane, they're said to be coplanar. Now let's take this example. This piece AEC, the vertical bar which is attached to the horizontal beam sort of a structure, right? This is acted upon by three forces: the force of 360 newtons pointing upwards, another 360 newtons pointing downwards, and notice both of them are actually applied at an offset of the width of that bar, and then there is another force of 600 newtons applied towards the right side if you look from the front. Now all these three forces are coplanar because they are acting on a plane that I have shown here in this picture. Okay, so that is what is coplanarity or coplanar forces. Let us take this example now. We're talking about concurrent. We looked at collinearity, coplanar forces, and concurrent forces now. So in this example, there are three members here. All of them are hinged to supports on the, two of them hinged to support on the point. All three of them are hinged in the center, and the bottom it is hinged to a weight of 100 newtons. Now I can remove this weight and replace it with a equivalent force of 100 newtons. Right? I can also remove the entire support structure on the top and replace it with the forces that the support structure would exert on those members. Okay. Now if I consider these three forces now, you can notice that they all are concurrent. Concurrent means they all intersect at a point which is in the center. They all have a single intersection point. In other words, their lines of actions intersect at a single point. If that is the case, they are concurrent forces. Look at this, another example of concurrent forces. Now you have this lorry on which this porter cabin is being loaded through this crane, and you can see this porter cabin is supported by four wires which are hooked at on the top of the hook, connected to the crane, and those four wires will have built up tension, as you can see the forces represented here in the picture. So all these four forces, you can only see three wires because the third and the fourth are overlapped with each other. So all these four forces are concurrent forces because the lines of actions of these four forces are intersecting at the top of the support. Okay, right. This is another example. All these three forces, 150, 120, 80. This is also an example of the concurrent force. So basically, let us look at whether they are collinear, coplanar, concurrent. Are they collinear? No, their lines of actions are not the same, and so they are not collinear. Are they coplanar? Of course, they are all in the same plane as the XY plane as is shown here in the picture, so they are coplanar. Are they concurrent? Do they intersect? Do the lines of action intersect at a single point? Yes. So in this example, we see these three forces are coplanar and concurrent, but they are not collinear. Okay, let's take another example. In this example, are they collinear? Do they share the same line of action? Of course not. Are they coplanar? Let us ask this question. That's the plane? Yes. So they are coplanar. Are they concurrent? Do they have the same line of action? Do the lines of action intersect at a single point? No. Again, in this example, are these forces collinear? No. Are they coplanar? Do they lie on the same plane? No. You can see that they're all oriented in all axes, in all directions. It's a three-dimensional orientation of all these four different forces. So they are not coplanar at all, although they may look coplanar from a projection point of view, but in the 3D they are not really. Okay, but they are concurrent because they all intersect, their lines of action intersect at the point of intersection, which is at the support. Now the final example. In this one, are the forces, all the forces, there are how many of them? 1, 2, 3, 4, 5, 6. 6 forces. Are they collinear? Do their lines of action lie on the same line? Of course not. It's very simple. We know that. Are they coplanar? Look, if you take this plane, you can say at least 2 of the forces are coplanar. If you take maybe this plane, you can say those two, 18 newtons and PE, are coplanar. You could take the other plane shown here. You could say the 34 newtons up and down are also coplanar, but not all the 6 of them. And therefore, the 6 of these forces are not coplanar. Are they concurrent? Do their lines of action intersect? No. So they are not concurrent. So we have here the case where they are not collinear, not coplanar, and not concurrent. So collinear forces, coplanar, and concurrent forces. So thank you for watching. I'll get back to you in the next video. Thank you very much.